All right, so this is finding the prime factorization. So before we go into finding prime factorization, first you need to know that a prime number is a number that has factors of only 1 in itself, and factors are numbers that go evenly into another number. So, for example, 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number because it has 2 times 2, which goes into it, as well as 1 times 4. 5 is a prime number because it only can be multiplied by 1 and 5. 6 has factors of 1 times 6. It also has factors of 2 times 3. So this 2 times 3 is what makes it not a prime number. Okay, so when we're going for prime factorization, we are looking for all prime numbers that are multiplied in order to equal number. So we're going to use what's called a factor tree. If we're looking for the prime factors of 75, first thing we're going to do is we're going to start by something times something else equals 75. So I'm thinking about quarters, and I know that 3 times 25 equals 75. So we're going to stop at 3 here because that is prime. However, 25 is not prime, so we're going to continue. What times what equals 25? And I know that 5 times 5 equals 25 because it's a perfect square. And so 5 and 5 are also both primes. So the prime factorization of 75 is where we stopped at each of these. It would be 3 times 5 times 5. And we can also write this, since there are 2 5s, as 3 times 5 squared, because 5 squared would be 5 times 5. So that is the prime factorization of 75. So now we want to know the prime factorization of 92. And first thing I notice is that it is an even number. So I know that it can be divided by 2. So when we start this factor tree, I'm going to do 2 and 2 times what is 92? It's 2 times 46. So we stop at 2 here because 2 is a prime number. However, 46 is not a prime number, so we have to continue there. And 46, I notice again, is an even number, so it can be divided by 2. 2 and 23. So 2 times 23 equals 46. Both 2 and 23 are prime numbers, so that's where we stop. So the prime factorization of 92 is 2 times 2 times 23. And if we were to write that with exponents, then it would be 2 squared, because there are 2 2's, times 23. And that is the prime factorization of 92. Moving on to another example, the prime factorization of 9. 9 is a perfect square, so we have 3 times 3. Both of these are primes, which means we would stop there. And so the prime factorization of 9 is 3 times 3, or if we were to write it as exponents, it would be 3 squared. Not too bad at all, that one. Moving on, the prime factorization of 48. First thing I notice is that 48 is even, so I know it can be divided by 2. So I'm going to start with 2 here, and 48 divided by 2 is 24. So 2 times 24 is going to give us 48. 2 is prime, so we're going to stop there. 24, however, is not, so we're going to continue there. 24 is also even, so that can also be divided by 2. So I know that there's 2, and 24 divided by 2 is 12. So we end up with another prime here, which is 2. This time we have to continue. 12 is not prime, so we have to continue here. 12 is also even, so I can divide that by 2. And 12 divided by 2 is going to give us 6. So I know that 6 times 2 is 12. This 2 here is prime. However, 6 is not, so we must continue that as well. 6 is also even, so we're going to have 2 times 3 is what gives us 6. And both of those are prime, so that's where we stop. So if we're going to write out the prime factorization of 48, we're going to get 2, that's this 2, times 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 3. If we were to write this as exponents, there's 1, 2, 3, 4 2's. So that means we're going to have 2 to the 4th power times 3, and that is our prime factorization of 48. Moving on here to the prime factorization of 29. 29 itself is prime. It can only be divided by 1 and 29, or its only factors are 1 and 29, which means that the prime factorization would just be written as 29. You would not write 29 times 1, just 29. And our last example here, we have the prime factorization of 36. So we can go about this a couple ways. I know that 36 is a perfect square of 6, so I'm going to write this as 6 times 6. Neither 6 is prime, so we're going to continue there. Here, this 6 is equal to 2 times 3, and both of those are prime, so I'm going to stop there. And we have to do this other 6 as well, which is also going to be 2 times 3, and both of those are prime, so we're going to write that, stop there as well. So 36 is going to be 2 times 2 times 3 times 3, and I put them in order by value. So I did the 2, 2, and the 3, 3. And then if we write this with exponents, that would be 2 squared because there's 2 2's, and then 3 squared because there are 2 3's. So the prime factorization of 36 is 2 squared times 3 squared. And that is prime factorization.